Here is a PID control using FreeRTOS that I already uploaded to the board, and I implement the PID in task 0 in here, so it's quite a complicated program, and I have several tasks here, and okay, here is the list. I implement the controller in task 0. Task 1 is for the implement the queue for data communication to the serial port that we can plot the step response. I remove the OLD display port simplicity, and also we have NETPIE freeboard which we will try later on. But right now I have omit the NETPIE, so I just set the NETPIE flag to 0. And also for this program I can do the plan simulation. If you don't have the board, the hardware for the lag 3, you can simulate using the code in task 7. So first here I have some flag in the program, and first I set NETPIE to 0 so that I don't have to connect to the Wi-Fi and the online stuff. I just want to compare the response of the PID to the to the simulation. So I have a notebook like this, and I write a function PID compare to compare the simulation from using Python control library with the real data, and I want to see how it looks like. Let's start the step response. First I want to check where is the output. Right now I use the command ryu, and it shows that the R, the Y, and the U data. Right now the pan output is about 0.3, so I want to set to this value. But first I want to set the output to some small value first, so I set it to 0.1, and I want to step from 0.1 to 0.3. The reason that I make a small step like this is that when we compare with the pure linear system, we don't want the saturation to affect the output. So if I step to 1, it is quite a large value, and it causes some saturation in the PWM. Okay, so let's check. Okay, so right now the plan is about 0.1, and I use the command step data for 0.3, and I execute this command. You see that the data is sent to the serial monitor, and the plan change. So we can copy this data and put into a cell of a notebook so that we can compare the step response. So let's do that. I copy the whole thing, and then go to the notebook, and I put it in some cell like here. Okay, first I execute the import the library. Use NumPy, matplotlib, and also the Python control library. Now I run this to have the data into the cell. Then I run this function. This function definition, it doesn't show anything, so we have to call this function PD compare, and compare the theoretical simulation to the data. So it looks like this. You see similar characteristic. Okay, but there is some delay on that. Uh, and for this system, it's a slow, a low bandwidth system, so some delay of 1 second. I'm quite okay with it as long as the it shows the similar characteristic, mean that the RPD control is behave as we want it to be. After we are satisfied with the step response, we continue with to make it an IoT by putting the NETPIE information into the program. Okay, so I have client token secret and I put this into my program, and now I can set the NETPIE flag equal to 1 so that it can connect to the NETPIE. Okay, upload add. Now we can see that now the device online and the data are written to the shadow of NETPIE. So this should be ready to create a freeboard, and we already have the freeboard from our previous program, right? So from the previous program, before we use FreeRTOS, we have a freeboard like this, like when I use PID with the timer, right? And this freeboard we can adjust the R value. Okay, so we want to add the PID parameters control to this freeboard, and that's what we want to do. And you see from this program that the freeboard update is happen in this function update freeboard, and whenever you adjust parameters such as KP, KD like this, it send the new value to the freeboard. Okay, and the way to adjust the parameter just like adjusting the step here, so you can, the code must look like this. Okay, when you stop the slider, you send this command, and instead of using step equal something, you change it to KPKAD and so on. So that's the idea how you have the control. So let's try to do it with proportional gain. If you want to have a slider to change the proportional gain, you have this. I can do it quite quickly here. Slider KP, you can adjust the color and the range of the parameter. Just keep it that way, and maybe the step is 0.1. And now you have to put the command just like you have on the slider here, so you can just copy that and edit it. Okay, I'll stop action. Message command is okay, but this one you just type KP equal to the slider position here, and also the auto update value you have, because you have the KP in the shadow, you can just select it like KP. So this is the slider for the KP. You see the value, the present value here. Let's see if the command can be received here. I change the slider. Now you see that the new KP changed to the slider position of 20.6 and it changed and the PD coefficient is updated. So you can do such thing for KI, KD and any other control that you want to have. So so after finish adding the sliders for PID parameter, you have something that looks like this, and you can adjust them. You see that when I adjust this slider, the value change and the coefficient get updated. So you can have some other widgets such as push button on the toggle switch. Let's make it for the some parameter. I have a parameter called A to D moving average in here. So ADMA. Okay. If I check the value, the current value for ADMA, right now the auto moving average is off. So I can set that to on to have the moving average in effect like this. So if you want to make a widget for this, you can add it and select it to be toggle switch, and you have to put that command to the on toggle off and on toggle on here. Okay, and I just copy the command. It looks like this because when the toggle is set to on, I want to set this command ADMA equal to on, right? That's why I type in the serial monitor. As well as for the on toggle off, I have this one ADMA equal to off. Okay, and for the state of the toggle, you need to have because ADMA is also written to the shadow. You can find it in the shadow here and ADMA. Okay, and you have to put in the condition statement like this because I want the toggle switch to be on when ADMA equal to 1. Okay, so the ADMA is written to the shadow as 0 or 1. So whenever the ADMA equal to 1, I have the toggle switch change to on. So it should look like this, and you see that when I click this and it changed to off. Okay, and the message aligned to ADMA equal to off, and it's set to off like this. Okay, so this toggle switch work. So this will get you some idea how to add the widgets to the PD control.